So friends, in this class we will be learning the data types that we use in C program, and we'll practice some example programs to demonstrate those data types. So first we'll understand what are data types. A data type is a keyword which specifies the type of data being stored in the variable. If you remember, when we were performing the program on mathematical operations and some other programs, we have declared some variables as well as we specified the type of those variables, right, using the keyword int and float. So int and float here are the keywords and they are the data types. Okay, all data types are keywords first, then they are data types, because a C program has a set of 32 keywords and some of them are data types which specify the type of data of the variables. Data types are used to define variables before to use in a program. So before writing the further program, in the declaration section we have to declare the variables with the data types. So the compiler will recognize the type of variables and the number of variables before it's going to execute the further program, right? So size of variables are determined by data types. There are situations where we store different kinds of data of characters, integers and floating type, real numbers. So there are different types of data that we store in variables, and so data types are used to find out the size of variables for the compiler. So by looking at the data types, compiler will find out the size of the variables that is going to allocate in the future, right? Data types are put before the variables in the declaration to specify variables type, as we did in the last programs. For example, int, num and sum. So here in this example, it's a declaration statement which declares two variables, respectively num and sum, of the type int. So int is a data type defining the type of data being stored in num and sum variables. All data types are keywords. So moving on, first we'll understand and know the different types of primary data types. So primary data types are also called as fundamental data types, basic data types, right? First comes the char data types, so which requires 1 byte of memory for a variable, right? Char is a data type which represents all the characters corresponding to the ASCII code between -128 and +127, right? So when you declare a variable with the data type char, it has to have 1 byte of memory for the character, and it can store any character corresponding to the ASCII code -128 to +127. So whatever comes between -128 to 127, that character can be stored inside a variable of type char. So int variable must require 2 bytes of memory if we are running the program in 16-bit word length computer. The memory size of the variable depends on the word length of the computer. If we are using 16-bit computer, so int variable must require 2 bytes of memory. If we are running the program on 32-bit computer, it requires 4 bytes of memory for a integer variable. Let us assume that we are running this program on the 16-bit computer, and we'll find out it later. And the integer variable, a single integer variable, requires 2 bytes of memory. And the range of value that we can store in an integer variable lies between -32,768 and +32,767. Whatever the number between these two values can be stored in an integer variable. So this is the range of a integer variable. You cannot exceed 32,767 right? If you want to have a more value in a integer variable, then you must go for the long variable. So long is a data type representing a variable which can store a longer value than the integer variable. So long variable must have, or it must require 4 bytes of memory, and we can store up to 2 1 4 7 4 8 3 6 4 7. So here we have the both negative and positive range. Whatever comes between these two range can be stored in a long variable, right? So we are assuming the 16-bit computer, a long variable in a 16-bit computer must require 4 bytes of memory. So for real numbers or with the numbers with the decimal value are stored in the float variables. So a single float variable requires 4 bytes of memory and can have 6 decimal in the fractional part, right? And the range for this float variable starts from 3.4 exponent minus 38. That means 3.4 into 10 to the power minus 38. And the maximum value that can a float variable have is 3.4 into 10 to the power positive 38. And the float variable can have a number with the fractional part consisting of maximum 6 decimal places. And a double is also type of a float variable, but it can have 14 decimal places after the decimal point, and you can find out the range of a double variable. And there is one more data type called void, which is an empty data type, normally used with the functions or subprograms. It cannot be used along with the variables, but it represents the return type of the function where we used it, right? Every function in the C program has to return something to the calling function. If the function is returning nothing, then we represent that nothing with the keyword void. Or void is an empty data type which normally specify the return type of the function. When the return type is nothing, just mention the word void. If the function is returning something in the form of integers, then start the function name with the keyword int. Okay. So friends, to demonstrate the different data types in C, I have declared all the various types of basic data types here. So I've declared a character variable C, integer variable I, long variable L, float variable F, and double variable D. So here we have got 5 different data types for 5 different variables. Okay, now let's go and find out the memory size of all these data types. So how to find out the memory size for this particular computer, for any particular computer? So C provides a special type of operator called size of operator, which performs like a function, and it returns the memory size of a specified variable. I'll declare an integer variable called size of type int, because the size of function returns, or you can call it as operator, it returns the number of bytes that a specified memory can hold. So the number is in integer form, so that's why we have declared the variable size in the integer form, right? So now I'm going to use this variable to store the size returned by the size of function, which consists of any type of variable. So let us say I'll put I here. Okay, so I've already declared the variable I, and when I put this I inside the size of operator, it will find out the memory required for the variable I and returns the number of bytes to the variable size, because I'm assigning the result of size of operator to the variable size. Now let's go and print the content of size, the variable size, right? Printf the memory size for integer is equal to %d comma size. So here I am printing the content of C, which has got the number of bytes for the variable I, which is of type int. Okay, let us add the clear screen. So remember, you must have this clear screen statement after all the variable declaration. Control F9. So the memory size for integer is 2. So I got the number 2 in place of %d, which is a placeholder for this variable size, right? So size has got now the memory size of integer I. So like this we can find out the size of any variable here. Here in this printf statement I have included the size of operator because I merged both in the single statement. So this will give me the character data type. So this will return the size of character data type because I have told here like the memory size of character data type is %d byte. Here in place of %d I am going to place the content returned by the size of function, size of C. Okay, here it returns the size of the variable C. So let's run this program and find out. So here it is. The memory size of character data type is 1 byte. Right? So let me copy this line and paste it for all the other data types. I have put 5 different statements for printing all the 5 different basic data types. So let's go and run this program. Here it is. We have got the size of character data type is 1 byte, integer data type is 2 bytes, long data type is 4 bytes, float data type is 4 bytes, and double data type is 8 bytes. Right? So this is according to my system. Okay, so you may got the different values in your computer. So this is the function. Size of function returns the number of bytes allocated for the specified variable. So this is how we can see the number of bytes or the memory space allocated for a variable. So these are the different types of data types we have got in our C language. So first let me save this file. So I will call it as datatypes.c.